So if you remember a few weeks back, we looked at that Radio Shack power booster for a car stereo. This time we're going to look at a real power amplifier made by Audiovox called the HCB860, I believe it was, 60 watts per channel with a real power supply. I've had this thing for 40 years. It still works. Let's check it out. Back in the 80s, a lot of car stereos used these under-the-dash power boosters. Kind of like that Radio Shack one I showed off before. And they delivered additional power by a couple different ways. One was by using a couple of IC, the positive leading one to operate the amplify the negative. So they used a bridge tied low to BTL output. And some of them used like that Radio Shack one, which had the two transistors operating through an output transformer to effectively double the amount of power by means of a transformer. And then there was the real amplifiers, like this one. 60 watts per channel, non-bridged load, that you can see the ground for the speakers is tied to ground. Drew some serious power, had a 20 amp fuse, power regulator, and power amplifier. This was from one of my oldest cars that I had it in. This was through several vehicles. I had it in a 1980 Mustang. I then put it in an 84 Capri, and then into an 86 5-liter Mustang. And then it even ended up in my Thunderbird, which is now, the Thunderbird is now parked in my garage, and I was going to put the original factory stereo back in it. And I stopped running these amps in my car. My car now has the factory stereo. The modern stuff, though, really it's hard to change on a factory stereo with all the speakers. Everything's all Class D amplifiers now, but with all the multiple speakers they've got now, it's tough to change out one, especially in an electric car, because the whole infotainment system is integrated to the car. So this is now just a piece of equipment that was in my old car, and it was sitting, actually it was in the trunk of the car. I took it out and just left it in the trunk. So let's take a look inside this thing. It doesn't have any screws in it, so we can actually see the inner workings and examine how this thing works and check out the design of this unit. This one's a real power amplifier. Okay, you've got your power amplifier section here. This is the power supply. This one's using a DC to DC converter. And look at the transistors this thing's got in it. It's got six transistors switching back and forth to take the 12 volts DC from the car battery and switch that over to a higher frequency chopped DC. So basically one bank conducts, then the other bank conducts, controlled by this control IC here. The transistors are driven back and forth to induce a 12 volt at relatively high current into this toroidal transformer, which will then produce a higher voltage AC signal in the secondary, which is going to be rectified by these dual diode rectifiers here, providing us with a positive and a negative supply voltage to these two main filter capacitors so that the conventional amplifier can work. This was the first of the inverter type. Let's pull the bottom off it. We're going to hook this thing up too and actually test it and see if it still works after all these years. Say this was my original stereo, first half decent stereo amp that I bought, and it went through 4 cars. This went through 4 cars that I had. I kept taking this one out and putting it in the next car because the thing sounded so darn good. This was a really good amplifier. Look at what they've had to do here. They've actually had to put braid down This is to beef up the current handling capabilities, because these transistors handle so much current that it would burn the copper, and the entire board itself is plated in solder to give extra current handling capabilities here. If we look at the output transistors here, they should all be wired in parallel. You can see the jumpers down here that are connecting the collectors together, the emitters together, and the bases together for these transistors. If we look at continuity between the bases, between the collectors and the emitters, I think that's the three. That's the basing of them. Anyway, they're connected in parallel. And here's our power amplifier. So if I connect power to this unit, I'll get my power supply going. We're going to fire this thing up, set it for 13 volts. My power supply is limited to 10 amps, so we'll turn it up all the way. I've got a power lead here. We'll connect up the power. And there's one lead I got to connect to turn it on. I think it's the pink lead. Let me look and see. Yeah, the pink lead is the power control. So this lead here, the orange lead over here, that was to control another preamp. So the pink lead has to go to positive. You can tell my wonderful tape job from when this was in the car. Did I solder it or did I just tape it? Probably just taped it. I would have been in a hurry when I put this thing in. You know, when I was young, and all I cared about, like every young man, all you care about is how quick can you get the stereo in that new car. Okay, power lead would be positive, and this one's ground. I don't think that ground lead would actually handle much current, but we'll just untape this. We're going to power this thing up, hook it up to some speakers, and see how this thing sounds. See how much power we can get out of this thing. I guarantee you I can get a lot of power out of it. 60 watts per channel, and it was. And this thing used to pound. The last car this was in, this was just one of many amps. This amp was one of many amps. This was the one that powered my subwoofers. I think I had some 10-inch subs in the back. I had another amplifier that was a little less power, that was powering up my tweeters and stuff. If we scope the collector of the transistors and I connect the power to the pink control line, you'll see that we have this is a times 10 probe, I believe. Yeah, I'm on a times 10 probe. So voltage wise there we have 10, 20, so about 25 volts peak to peak. You're wondering, how are we getting 25 volts? You can see it's set to 1 volt. Well, that's what we're getting, 25 volts, even though we've only got 13 volts going in. You're getting kickback from the transformer as well. If we look on the digital scope, so we can see what the frequency this is, it's not very high. It's 21 kilohertz, looks like. 21.3761 kilohertz. So it's not a super high frequency power supply, but it doesn't need to be, because it's just going to be filtered to DC. 21 kilohertz is above any frequency that you're going to hear. Even if there was ripple, you're really probably not going to hear it. But we're looking at the same voltage on here. It's 5 volts per division, 5, 10, 15, 20, 20, yeah, 25 volts, which is about double what the input is. So here's our secondary. As you can see, if we bring this up here, where are we here? I should probably go to AC coupling, but we're now looking at 20 volts per division. There's some things that digital scopes work out better on than analog scopes, and voltage measurement is one of them. If I click on measure here, 21 kilohertz, we know that because it was here. We are looking at a peak of 69 volts. So our 12 volt input, if I go back to the collector here, we can measure this here. Here's our voltage, 27 volts. Don't have to count anything, it just tells me. That's one of the nice things about the digital scope. I've got both for a reason, because the analog scope for some things is better, like setting up VCRs and stuff, just because this digital scope I've got here is not a real high-end one. It's 100 megahertz, and it gets the job done, but it's lacking at looking at complex waveforms, like looking at video and looking at RF from a CD player, for example. It's a joke. But for looking at digital signals, like from switching power supplies, you can do a lot more measurements with this. It's much simpler to see. Same as when I'm checking the speed for tape decks and stuff. I can look at the frequency. It'll read the frequency right out. In this case, 21.33 kilohertz. So that's the collector going in. If I look at the base drive, we can see that too. I'll have to crank up the gain, but here's the base drive signal. And where's my trigger level? I'm adjusting my trigger level here on this thing. There we go. Now we're stable. We're looking at the negative pulse. This line here is my trigger level. You can see when I'm adjusting it. So I can synchronize to that. So that's the base drive that's driving the transistor, the MOSFETs on and off. And then we go back to the collector. Of course, the collector, I gotta and then if I go over to the secondary, this is the secondary side, 68 volts, and there should be two of them on here, so this other one here should be the same. Another nice thing about the storage, or the DSO, and I should really learn more about a lot of the features on this, because I don't use a lot of the features, but for example, if I want to measure something that's unknown, if I just press the auto button here, it's going to automatically set up the range for me. Right, it now measures at 68 volts, sets the range. As long as it knows that I've got a time-to-time probe, it will automatically set the range, automatically set the frequency, like the sweep, which is nice. If I want to go back and measure that base drive again, I just hit the auto button. It'll automatically set the levels. I don't have to mess around with anything. It'll automatically set everything. I don't have to set anything. That's one of the strengths of the digital scope. So let's take a look and see what our working voltage is to the amplifiers. Where are we here? Minus 33 volts on one, and plus 33 volts on the other. So we have 66.9 volts is what we've got to work with. So 67 volts off the power supply. And that'll give us 60 watts per channel. And we'll get 60 watts with that kind of voltage per channel. So now I'm going to connect this thing. I'm going to power it down while I do this. I'm going to connect this thing up to a music source. We're going to hook it up to some speakers and take a listen to it. Okay, I've got it hooked up to the line outputs from my MP3 player. It's got a variable output so I can turn it down, otherwise it would be full volume. And all you got to do is just connect up the power lead for the control. That'll turn on the power. just so happens it was right at the track change. Show you guys the waveform quality. Give the same bit of volume. Oops. I'm sure Rick Hart's making a claim to this. I can just see it now, even though we thought that's been settled. I'm sure it'll come back again. That's one that he put words to. Sound quality of this thing is amazing. It's every bit as good as my shop amp here. I mean, because it is a real amplifier. It's a real class AB amplifier. It just runs on 12 volts. It's got a power supply to kick the voltage up to the 60 odd volts it needs, or 60 watts per channel. And it does a really good job. This was one of the first of the real amplifiers, this Audiovox unit. Because prior to this, everything that was out there was this. This is what we dealt with. This and other ones similar to this, power boosters. But we dealt with this type of technology that just worked on 12 volts. And you're limited by how much current and how many watts you could pull from 12 volts. This one here was the first of the serious amplifiers that Audiovox brought out, and this was out long before a lot of the other ones. You had the Alpine and all the others followed, but this is very early. I think I got this in 1980, somewhere around there. 80, 81. This very old one. So here's an ad for it. They're saying 130 watts total power, 65 per channel, from 15 to 20 kilohertz, and the 0.3% total harmonic distortion, dual 4 to 8 ohm impedance connections, remote power on off, selectable or high or low level inputs. List price was $200. So let's see if I can find when this article or when this ad came out. To put it in perspective, on the same page is the smallest stereo cassette player by Sony, the TPS 12, looks like. It's billed as the world's smallest such stereo tape machine capable of providing full quality hi-fi sound. It's the size of a pocket dictionary. This is before the Walkman. If anybody remembers that one. I don't remember that one myself. But it's got to be 1980. I'm pretty sure it was 1980 when this was around. Anyway, look back in the top of it before I put it together. It's basically a dual mono type design. You got a separate op amp for each channel. And the two amplifier sections, they share the same power supply. But the two amplifier sections are, you can basically draw a line right down the middle. And they mirror each other. Channel 1 from here over and channel 2 over there. Output transistors on this are 2SD705 and 2SD745, both NEC devices. Nothing fancy, they're just standard bipolar power transistors, an NPN and a PNP. Wired in a conventional Class B, bias would be Class AB amplifier design. Anyway, that's it. One of the first true high power amplifiers for automotive use. The High Comp by Audiovox HCB860. They say 60 watts per channel, but a lot of the advertising material said 65. Anyway, thanks for watching. It's good to see this old stuff still working after 40 years. And this thing, I tell you, was abused. I abused the crap out of this thing, and I never managed to blow it up. That shows how good this thing was built. Thanks for watching. Be sure to hit that subscribe button, and we'll catch you in the next one. Bye for now.